just to remind you, the kind of way that the easy, quick and dirty way that a lot of people learn to prove this is with the triangle, okay? But can you remember what the problem was with the triangle? Yeah, that's right. It restricts you a lot. When you form this triangle, and I think it's, let's see, opposite, one, adjacent. So this is the right-angled triangle that you form, and you can try and see the ratios from there. Obviously, because it's right angle, this means theta must be acute, right? So between 0 and 90, exclusive. It doesn't even include the boundaries, right? But we want to be able to use these t results all the time, and you can, right? So that's why this proof is bogus, okay? Now, I showed you earlier one proof with identities. So I'm not going to redo that one because you can go and watch the video. That's why I take videos, okay? But I have another proof, and I think it's a bit faster, okay? So that's why I've called it alternative proof for t results, okay? So I guess this is, I guess it's an alternative proof. Because it's the third one. Right? So I reckon this is probably, it's the fastest out of the ones that I've given you. So where do we start?
Including the triangle one?
Including the triangle one. Well, maybe it's about the same as the triangle one, but the triangle one is part dodgy, so it's not that good of an option. So where do we begin? What is the t in t results? What does it stand for? Tan theta 2, good. Okay, now obviously always, because we're talking about tans, right, the first place you go is just tan theta, not theta on 2. Okay, so you can just use a straight substitution of the double angle formula here. So you're going to get 2 tan theta on 2 on, and so on. But since we know what tan theta on 2 is, we're just defining it as t, you end up here quite quickly. Okay, so no props, right? Now, I think in my earlier proof I started with sine. Well, actually, I can't remember. But this time I'm going to start with cosine. Okay. Now, again, just like with tan, I'm going to use the double angle formula. Okay. What's the double angle formula for cos? If I said, say cos 2x, what's that equal to? Good. Now, this is right. There are several, but they all come back to the same one. Okay. So. Okay. So the basic one is this, cos squared minus sine squared, okay, from which you can convert that into two different other ones. You can convert it into one which is all sines, right? So you go 1 minus 2 sine squared x, right? So that's all sines. Or you can go the other way and you convert it into all causes, right? So you get this. Yes, does that ring bells? Okay, now, just looking at what I'm trying to prove, right? I'm trying to show that cos theta is going to be 1 minus t squared on 1 plus t squared. So all in terms of tans, okay? Now, out of these 1, 2, 3 options, which do you think would be best? You have a think. I think we can kind of rule out the middle one, right? Why would the middle one not be that useful for us? Because it's in terms of two different functions, right? So you're going to have to substitute two different things. That's a bit awkward, right? So then your option is, well, which of these would be more useful, right? Now remember, since we're trying to get things in terms of tans, right, tans, which of these would be easier to turn to something in terms of tans? The top one or the bottom one? This is interesting. Okay, I won't make you put your hand up, but I want you to write at the top of your page right now which one you think, the sine one or the cos one. Commit, have a think about it, right? Write it down first. I want you to make a decision, okay? Because this is kind of important. Even though I'm going to show you this, and you can memorize it. It's not that hard. It's not that long. You need to be able to have this skill, right? When you have, whatever identity, left-hand side equals right-hand side, and you have to make some decisions about what identity should I use, which will get me from one side to the other fastest, okay? So which one is it? Now, having written one down, have you all written one down? You're an option? Yeah? Okay. I'm going to go for the bottom one. Okay. Now, you're like, yes, or no. Okay, so let me try and justify it. First, I'll write it down. Now, because what I've got here is theta, not 2x, right? That's what turns this into a theta on 2. Yes? Okay. Minus 1. Now, remember, my destination is all in terms of tans, okay? And the easy identity that I can think of, which involves tans and cosines, right, especially when it's squared, is I'm going to use sec squared. Do you remember that one? Okay. So in order to use sec squared, I'm going to turn this upside down, which is a little awkward, reciprocal of a reciprocal, okay? But sec squared whatever, I know what that's equal to in terms of tans. If you go back to the Pythagorean identity, whoops, plus. Okay, if you divide the whole lot by cos squared, okay, what do you get? Divide that through, you get tan squared. Divide that through, you get 1, and on the right-hand side, that's where that comes from. I always confuse the sec squared one. This one's easy to remember, but this one you use like half as often. So if you have trouble remembering, that's how I do it. Okay. Now, that sec squared is what I have on the bottom here. So that's 2 on 1 plus tan squared. Don't really need that. Okay. You probably could do something with sine, but I just think it's less direct. Okay. So now that I've got this tan theta on 2 in there, I'll just substitute it for a t. And this minus 1 over here, I can bring on top of the fraction, combine these two. Okay, so I'm going to get a 1 plus t squared on the top, and you can see that's how I arrive here. That's cos. Okay? So this is what I mean. I'm pretty sure this proof is quicker than the previous identity proof that I gave you. Okay? But that's mostly it, really. You're like, oh, but I got to prove the sine one. It'll take at least as long, right? No, it doesn't, because I've got tan and I've got cos. Well, sine, right? Sine on cos, that's tan, right? So therefore, sine is tan times cos, right? And I know what both of those are. Okay, so that's 2t on 1 minus t squared times that, and you just get the cancelling. Okay, so 2t on 1 plus t squared, and you're finished. See, I mean, I think probably the hardest things to remember in this proof are, number 1, get that form, right? Number 2, remember that you can use this sec squared identity. Those are the hardest parts, and that's not that hard, and it falls out quite quickly. Okay.